Okay, so now we're going to try a different set of data here.
All right.
How about this one? So, what do you think's going on here with?
Well, now we've got it sort of split into quadrants here.
Okay.
And we've got blue dots are kind of opposite, and then orange dots are kind of opposite each other.
Okay, so now we're going to try to come up with a program that classifies these dots. And let's do the same thing before we run that program. Like if I put in a new dot and it was over here, what would you say it is?
It would be orange.
You would guess orange, and how about over here?
That would be blue.
Okay, so do you think this is an easier or a more difficult or about the same classification problem
I think
as we had
it's
before?
an easier problem because you can sort of split it into quadrants and then...
Alright, so can you point to me where a place it might be difficult to tell?
Maybe like in the center.
In the
because
center,
you've
okay.
got equidistant from all quadrants here.
Okay.
But I'm sort of seeing this feature here that really just looks exactly like the classification.
Oh, interesting. So why don't we put that feature in?
And if
maybe
we take out these other two and see
Okay.
what it does.
Okay, sure.
So even with only that one feature, it classified it really well. It's almost as good as the other one did.
That's really interesting. So what do you think made this one easier?
Well, the fact that we had a feature, this feature here, that was almost exactly the same, or probably exactly the same as our data set that we had.
Okay.
And even with deleting the other features, then all the neurons sort of look the same, and we're not really changing much.
Yeah.
These all kind of look the same as that one.
Okay, so this turned out to be a little bit easier. Now, so there's actually, you can play around with this a little bit, and so we can add a little bit of noise to the data. What do you think noise is?
Well, I would maybe like the data is kind of less defined. See, we have some blue dot, we have an orange dot here where there should be blue dots, and yeah. So it's kind of like disrupting the data a little.
Okay, so why don't you run your same model here with a little bit of noise in the data and let's see what happens.
Here we've almost got it right, but there are the outliers again that are in the wrong spot.
Okay, so maybe, what if you use the same model as you had before? I wonder how it changes, if at all.
So these two.
Yeah. So we add that in, and now we have a little bit of noise, which makes it maybe a little bit more realistic.
So it's like it's not really getting it right. It's all these blue dots over here are said to be orange. I just kind of forgot those dots.
That's interesting. What if we take the noise away first? So what do you think happens if I take the noise away?
Well, now the data is really defined into the 4 quadrants here, and it's about the same as the other one.
Yeah, so that was an easy problem, and then when I added some noise, all of a sudden our more complicated model seemed like it was behaving a little strangely.
Yeah.
Although interestingly, this time
It's got the blue
slightly
dots
less
right.
strange.
Yeah.
Okay. All right, so let's go to the next step, or next problem.